This is section 1-4, Vacation Expenses. Interesting quote to start off here. For my part, I travel not to go anywhere, but to go. I travel for travel's sake. The great affair is to move, by Robert Louis Stevenson. I feel this quote is probably especially appropriate for us right now during this whole COVID-19 situation, because after being cooped up in a house for a long time, you do want to just get out and go, all right? So, and that's sort of what he's talking about here. In terms of the objectives of this lesson, we're going to talk about measuring dispersion using standard deviation units. We're going to talk about computing z-scores. We're going to talk about finding percentages using the normal curve. And lastly, computing raw scores using z-scores. All right, let's look at some key terms that we're going to need to understand and define. First of these is z-score. A z-score is how many standard deviations a unit is away from the mean. Remember, the mean is the average, and how many standard deviations it is away from that mean, that is the z-score. Next is normal distribution. This is a description of data that has the normal curve as a graph. All right? And then normal curve, which is shown at the bottom of this slide, is the areas under the curve represent the percents of data in specified intervals. The shape is a bell curve. So the normal curve looks like this curve that's shown right here. And as you can see, the middle of it, okay, and let me just mark it here so we can see what we're talking about here. The middle of it is the mean, okay? So there it is right there, all right? And now, and notice then you've got out here, at this point here, and this point here, you've got the mean minus a standard deviation, the mean plus a standard deviation. This represents 68% of the data. If you go 2 standard deviations away, you get 95% of the data. And if you go 3 standard deviations away, you get 99.7% of the data. Now, as you obviously saw from the last slide, we're going to talk about graphs which are going to help to describe frequency distribution and give a more visual representation of our data. So let's look at example 1. A summer camp is taking their 220 sixth graders on a trip to an amusement park. For safety purposes, some of the rides have height requirements. The campers' heights have a mean, okay, and that's represented by this Greek letter here, mu, of 56 inches. And a standard deviation, represented by this Greek letter here, of 3, okay? So the mean is 56 inches, the standard deviation is 3. What is the z-score, all right, for a camper with a height of 62 inches? All right, so this is the formula that we're going to use right here, all right? And in words, what does it say? It says the z-score is equal to whatever the person's height is minus the mean divided by the standard deviation. Okay? So, their height is 62 inches. The mean was 56. The standard deviation was 3. So if we calculate that, we come out with 2. Now, what does this 2 mean? This means that the 62 inches is 2 standard deviations above the mean. Okay? So, if you think about it, the mean is 56, the standard deviation is 3, so 2 of these is 6, add 6 to that, you get your 62. So that's what we mean by the z-score. It represents how many standard deviations the value is above the mean or below the mean. All right, let's look at another example here. The height of a certain student on this trip had a z-score of minus 0.5, or the student's height is 1/2 a standard deviation below the mean. What is the student's height in inches? All right, we use the same formula, okay, that we used before. Now we plug in, we know z, that's equal to minus 0.5. We know the mean from the previous, because it's the same data, is 56. Standard deviation is 3. If we solve for x, we come out with this person's height is 54.5 inches. All right, let's look at example 3. We're still going to be using the data from example 1 and 2, okay? And it says, a certain ride requires riders to be at least 51 inches tall, okay? So that's the minimum height that they can be. The heights are normally distributed, okay? That means they're using a normal curve, okay? That's whenever you say normally distributed, with a mean of 56, all right? And a standard deviation of 3. Approximately how many of the camp's 220 sixth graders will not be allowed on the ride? In other words, what we're asking is, how many of the sixth graders are less than 51 inches tall? All right, so let's look. We got the normal curve because it's normally distributed. Now the mean is 56, so that means right in the middle here is the mean. And the minimum height is going to be 51. So therefore, this shaded region here, the shaded region represents the percent of campers shorter than 51 inches, okay? So let's calculate the z-score again. Okay, same formula as we've used in the past. All right, so we're going to say that the person is 51 inches tall, the mean is 56, the standard deviation is 3, so we come out with a z-score of minus 1.67. All right, now we need to go to a z-table to determine the area, the shaded area here. Now, z-tables are available in your textbook in the appendix at the very end, but I've copied one over here, so let's take a look at it. Okay, so I've got a z-table here, and notice it says standard normal distribution right here, all right? And we want this area shaded on the left of the mean. All right. So we said it was minus 1.67. So if I look at minus 1.6 here and then 0.07 here, I come out with this right here of 0.0475. So that's the area of the shaded region. The area of the whole curve is considered to be 1, okay? So this is 0.0475. So if I multiply that by 100, I get 4.75%. Therefore, 4.75% of the students are less than 51 inches tall. Or the total number of students, 4.75% of 220, comes out to be 10.45. Okay, so there's approximately 10 students that are shorter than 51 inches and will not be able to go on that ride. All right, let's look at another example. The families of students at Smithtown High School were surveyed about their vacation expenses. The results were, again, notice, normally distributed with a mean of $2,313 and a standard deviation of $390. What percent of the families took vacations that cost between $2,000 and $3,000? All right, so let's take a look how we're going to solve this. All right, so let's look at this. Again, we're normally distributed, so we got a normal curve like this. We have a mean of 2313. Now we want to find this shaded region here, okay, between 2,000 and 3,000. So what we're going to have to do is figure out the area of this region below 2,000, figure out the region below 3,000, and subtract the 2 to get this region in here. All right. So let's start with the 2,000 figure and figure out what we've got for an area in this region here. So again, using the formula for z-score, we have this value, 2,000, minus the mean, divided by the standard deviation, comes out to be minus 0.80. Now, if we look back at the z-table, the area below z is, the z-score, therefore, is minus 0.80. All right? Which means the area, you come out with an area of 0.2119. Now, let's figure out the values for 3,000. Again, same formula. We use 3,000, the mean, standard deviation, and we come out with 1.76. The area below z equals 1.76 by going to the table comes out to be positive 0.9608. All right. So now we're looking, so this area on the left of 2,000 is 21.19%. The area to the left of 3,000 is 96.08%. So what's the area between the two? We're going to subtract the two, and we come out with 0.7489. This means that 74.89% of the families had vacation expenses between 2,000 and 3,000. All right, let's look at our last example here. A local travel magazine rates hotels using integers from 0 to 100. Last year, they rated over 2,000 hotels. The ratings were normally distributed with a mean of 78 and a standard deviation of 6.5. How high would a hotel's rating have to be for it to be considered in the top 10%? All right? So basically what we're looking for is, here's the normal distribution curve. We're trying to find out this area here, okay? That area there is 0.1. So that means the area to the left of that is 0.9. This area is 0.1 or 10%. So let's see how we're going to calculate this. All right, so let's start by looking at the normal distribution table here. All right, so we're looking for a value of 0.90000. Well, this is the closest looks like we're gonna come, 0.8997. So what does that correspond to? That corresponds to 1.2, looks like 1.28, okay? Again, using the same formula we've been using, that's a z-score of 1.28 is equal to x minus 78 divided by 6.5. So 78 was the mean, 6.5 was the standard deviation, so we come out with a value of x equaling 86.32, which means a score of 87 will allow the hotel to advertise that it is in the top 10%. Notice, even though it was 86.32, if I had said 86, that would have been below. So we want the next integer above 86.32. That's why we say a score of 87. Okay? And that will allow the hotel to advertise that it is in the top 10%.